Another odd general relativity forecast has come to the world. Wormholes, those fantastic sounding passageways to the far side of the cosmos, balance in a similar manner. Following their 1935 forecast, research appeared to indicate that wormholes were not a part of reality. However, recent research provides suggestions as to how they might develop, and the procedure may be simpler than previously believed by physicists. Wormholes are one of the many fascinating things in outer space. Scientists have pondered and studied wormholes for a long time, but they have recently discovered the first wormhole ever. Stay till the end of the video to find out how researchers can prove that wormholes exist. Welcome to our channel, where we provide you with facts related to space and technology. Before heading on to the video, make sure to like this video, subscribe to the channel, and hit the bell icon so you may never miss any of our updates. A wormhole is both interesting and terrifying, as you will discover. Scientists have learned a lot about wormholes and even built one, but what is it exactly? When two distant points in space or time are connected by a wormhole, which is an answer to the equations explaining Einstein's theory of general relativity, the length of the tunnel is shorter than the distance between the two sites. Therefore, you can think of wormholes as a shortcut between them. Even though they have been depicted in numerous science fiction movies, wormholes have remained purely theoretical for a long time. However, with the current finding, that is no longer the case. According to the wormhole hypothesis, enormous distances throughout the cosmos could be shortened by a fictitious transit through space-time. General relativity makes wormholes a possibility. Be cautious though, as wormholes pose risks such as abrupt collapse, intense radiation, and potentially hazardous contact with unusual materials. You may have heard of wormholes referred to as Einstein-Rosen bridges, since in 1935, the eminent scientists Albert Einstein and Nathan Rosen found the basic wormhole solution. The pair began by calculating the mathematical formula for a black hole. According to the laws of physics, a black hole is a singularity or a point of infinite density with an event horizon region surrounding it from which no item can escape. They discovered that they could extend the solution to include white holes, which are the opposite of black holes. Einstein and Rosen discovered that for every black hole in space, there exists a white hole. However, since the two holes will indeed exist in completely separate locations in space, a tunnel would connect the two ends, and this tunnel is known as a wormhole. These white holes also contain a singularity, but they behave in reverse to a black hole in that they don't allow anything to enter their event horizon, and any material inside a white hole gets spit out immediately. Even though wormholes are possible, stability was a problem, since a single photon or light particle going through the wormhole tunnel would add so much energy to the system that the tunnel would shatter, eradicating the wormhole. However, researchers finally found a way to create a stable wormhole and even make it traversable. If you had previously imagined a wormhole as a cozy secret passage you could take from one part of the universe to another, you might be mistaken, since you can only enter from the dark hole side and would have to cross the event horizon in order to do so. You will be saved from being an eternal prisoner in said wormhole by solving a few mathematical equations. Stabilizing a wormhole involves stabilizing the tunnel itself and relocating the wormhole tunnel's entrance outside the black hole's event horizon, so that the matter flowing through doesn't immediately and catastrophically collapse. Researchers found that negative mass matter, often known as exotic matter, is necessary. Negative mass is an interesting concept. For instance, if you position an entity with a negative mass beside an object with a positive mass, it will immediately accelerate. Even without any source of energy, mind you, exotic matter is different from dark matter or antimatter. There is also the issue of size. The exotic matter has high negative pressure and a negative energy density. Only in the behavior of specific vacuum states has the such matter been observed, according to quantum field theory. Recent research found that wormholes containing exotic matter could stay open and unchanging for longer periods. The expected size of primordial wormholes is between 10 and 33 centimeters. But as the universe expands, some have likely been extended to higher diameters. Let's imagine that you would be inside a wormhole. Researchers showed it would be odd if the entrance would be a sphere like you were searching at the surface of a planet. If you looked into the wormhole, you would see light coming in from the other side. The wormhole tunnel might be any length, and while gliding down the pathway, you would see warped views of the region, the multiverse you came from, and the region you were traveling to. In addition, wormholes can make a common notion in films a real time machine. Let's start with special relativity to see how this works. A wormhole's two ends would initially be synchronized in time, but if you accelerated one end to nearly the speed of light, that end would start to lag behind the other end. The two entrances could then be managed to bring together, but then one of the entrances would be in the future. This is consistent with the theory that moving clocks run slowly, which states that someone traveling at nearly the speed of light would not advance into their future as quickly as someone standing still. With all the studies into wormholes, we have not yet seen one in space, but a team of researchers took it upon themselves to create one in the lab. If this effort makes you nervous because of what might happen if things go wrong, stability is the issue. The projected Einstein-Rosen wormholes would be unstable and worthless for travel. You only need to walk through one end to travel back in time. By the time you exit the wormhole, you will be reveling in your own past, so you can literally relive some moments of your life. They claim that the mathematical theories of Alan Greenleaf, a professor at the University of Rochester in New York, served as inspiration. Greenleaf proposed a theory for an electromagnetic wormhole that would allow electromagnetic waves to travel through an invisible tunnel between 2 points in space. But his theory was never tested for a number of reasons. However, the Spanish team was able to create a wormhole using magnetic raw materials and metasurfaces. They might already exist, making it simpler to obtain them, according to one of the researchers, Geordie Prackham, who said that following considerable investigation, they realized the viability of the Greenleaf concept. After the team completed the design, it took 4 months to build the wormhole. The overall result is that a magnetic field appears to go from one point to another through a dimension that is outside of the typical 3 dimensions. The wormhole in this research is a sphere with 2 inner layers composed of superconducting material and a ferromagnetic sheet that is rolled into a cylinder that spans the sphere from one end to another. The sphere is designed to be magnetically invisible from the outside, invisible in magnetic field terms. The magnetic wormhole is analogous to gravitational ones because it alters the topology of space, making it appear as though the internal region has been magnetically wiped away. These researchers had previously created a magnetic fiber, a device that could transport a magnetic field from one end to the other. However, the fiber was magnetically perceptible, whereas the wormhole is not. While researchers are still attempting to discover the truth about wormholes, the concern is how they can prove that wormholes exist. For example, magnetic fields are used extensively in the medical field. The technology can help patients feel more comfortable during MRI scans by allowing them to be far from the detectors. It can also help get MRI images of multiple parts of the body instantaneously. Even if wormholes could be detected, current technology cannot stabilize or enlarge them. However, in the hopes that technology will one day be able to use them, scientists are still researching the idea as a means of space travel. The calculations indicate that a spectacular display of gamma rays would ensue from the accident, which we could attempt to witness with telescopes. This emission can aid in determining the difference between a black hole and a wormhole. Black holes should emit less gamma radiation and inject them into a jet, while radiation created by a wormhole would be contained to a massive sphere, contradicting the previous belief of scientists that the two couldn't be distinguished by an observer on the exterior. Do tell us your views in the comment section. If you have reached this far, like this video, subscribe to our channel, and press the notification bell so that you may not miss any of our future updates. See you in another video. Until then, take care.